Hello everyone, welcome to my channel. Today I will discuss about mechanism of action of antiepileptic drugs. Antiepileptic drugs acts by two ways. One way is decreasing the glutamate activity and another way by increasing the GABA activity. So let's see how the drugs decrease the glutamate activity. So if we think that this is a presynaptic neuron and this is postsynaptic neuron. So here is a voltage gated sodium channel. So normally what happens? Sodium enters into the cell, action potential activated, uh, there is depolarization and seizure activity. It also activates the calcium channel. Here is the calcium channel. Then influx of calcium occurs. This calcium binds with vesicles. So there are vesicles that contains neurotransmitter glutamate, and calcium acts on the receptor called ASV2A, and this receptor is present on this vesicle membrane. So when calcium binds with this ASV2A receptor, then the vesicle membrane is fused with the presynaptic neuron membrane, and then release of glutamate neurotransmitter. Then it binds with the two receptor. One is AMPA receptor and another is NMDA receptor, and these two receptors are present on postsynaptic neuron membrane. So when the glutamate neurotransmitter binds with this receptor, the receptor activated, then influx of sodium occurs, so there enters, so there is a depolarization of the cell, action potentials increased, and there is increased seizure activity. So what are the drugs do here? If we block this sodium channel, there will be no influx of sodium channel, no depolarization, no action potential, and no calcium channel activation, and no release of glutamate. So there the seizure activity will decrease. So there are drugs that blocks the voltage gated sodium channel. The drugs are valproate, topiramate, carbamazepine, oxcarbamazepine, and phenytoin. So another way the drugs works are calcium channel blocker. If we block this channel, so no influx of calcium, no fusion of calcium with this vesicle membrane. So calcium channel blocker are ethosuximide, valproate, lamotrigine. So we can see that valproate acts by both blocking the calcium channel and sodium channel. Here is another drug called levetiracetam. It blocks this receptor called ASV2A receptor. So if the levetiracetam block this receptor, calcium will not bind with the vesicle membrane, so no release of glutamate. So if we also block these two receptors called AMP receptor and NMD receptor, and this receptor will not be activated, no influx of sodium, no action potential, decreased seizure activity. So NMDA receptor blocker are felbamate and AMP receptor blocker is topiramate. So these are the drugs that acts by decreasing glutamate activity. So what are the drugs that increase the GABA activity? If we think this is a GABAergic neuron and the vesicle containing GABA neurotransmitter, we all know that GABA is a inhibitory neurotransmitter. So what happens? How epilepsy occurs? When the GABA is released from this presynaptic neuron, then the GABA binds with the receptor present here. This receptor is called GABA A receptor. GABA A receptor activate GABA A receptor are, when GABA A receptor is stimulated or activated, what happens here? Chloride enters into the cell. So there is calcium channel opening and more calcium in the cell. Calcium. So here is more negativity. More negativity means hyperpolarization of cells. So when there is hyperpolarization, decrease action potential, decrease seizure activity. Okay, so if we activate the GABA A receptor and more and more, so the seizure activity will decrease. So there are drugs that uh, acts by activating GABA A receptor. These are benzodiazepine, barbiturates, and topiramate. Benzodiazepine acts by increasing the frequency of chloride channel opening. It will help more and more calcium channel opening, and barbiturate increase the duration of chloride channel opening. And another drug, topiramate, also acts here. So topiramate has dual action. Topiramate both acts by increasing GABA activity and decreasing glutamate activity. Okay, well, so when GABA is done with performing its activity here, then rest of the GABA is reuptake by GABA transporter 1. Then it will destroy by some mechanism or metabolized by a enzyme called GABA transaminase enzyme. Okay, so if there is more and more reuptake of GABA, there will be less GABA here, less chloride uh, influx, less hyperpolarization, increase action potential, and increase seizure activity. So if we block this pathway, that means if we block the reuptake of GABA, we here will be more GABA and here will be decreased seizure activity. So triagemin is a drug that acts by decreasing this reuptake of GABA. So another drug that called valproate and vigabatrin acts by decreasing the activity of GABA transaminase enzymes. So normally GABA transaminase enzyme is metabolized GABA. So if we block this enzyme by these two drugs, it will increase the GABA level. Then GABA will be more, here will be more GABA, and then it released from this neuron and it will act more. So thank you for today. This was all.